Okay, just going to go through the next solution here to this one for the refraction of water waves, which is quite tricky. Now, the first example, we're going to go from deep water to shallow water. And then in the second wee video tutorial, we'll go the opposite direction. We'll go from shallow towards deep. Now, again, much like the previous worked examples there, can you just make sure again when you're doing this to have a good sharp pencil and a 15 and 30 cm. It needs to be a see-through ruler so you can sort of gauge whether lines are parallel and whatnot. The first thing I'd recommend you do is just copy out this diagram reasonably accurately. You can see it's inside like a wee ripple tank system here. These blue lines here represent, again, your wave crests, like it's like a plan elevation, like a bird's eye view again. And then these wave crests meet this boundary. And at this boundary, we're going from deep water and we're then moving into shallow water. And what you're really asked to do in the past papers is to sort of continue to show what happens those rays or water waves as they're refracted and they bend and then move in the actual shallow water. So just take a screenshot of this or just pause the video and spend a little bit of time, take a good page, well, maybe half a page, and just copy out the diagram fully. And then we'll go on to stage one then. Okay, so for stage one here, like again, quite similar to the previous video tutorial when we're doing like reflection of water waves. Just go to your very first wave on the left-hand side and the last full wave. So you can see it hasn't hit the boundary yet. And just put down two wee axes just basically at the midpoint. So grab a ruler on your page, come down approximately, and just put an X at those two locations. The next thing we're going to go on to here is to draw in the incident ray. So when you've got those wee axes down there, like just put your ruler down and then just draw in a line to connect those two axes. What you're really doing now is putting this incident ray right down through the very middle of your incident waves. Again, add an arrow in there to indicate the direction. And of course, if you've marked your two axes nice and accurately, then that incident ray should be 90 degrees to these blue wave fronts. So again, you can just pause the screen and undertake that exercise as well then. Moving on to number 3 now, we have to draw in our normal. So again, just go into your boundary here. You need to be coming off that boundary at again an angle of 90 degrees. So put your ruler down. It is definitely quite useful to have a see-through ruler here. You can, of course, that's ultimately the edge of your ruler. And if you use some of the actual nicks or numbers on the actual ruler, just put those wee nicks on top of the boundary. That ensures you get an angle of exactly 90 degrees. Put a wee capital N up there. Make this line dashed again like a wee gaps in between, like a wee construction line, so to speak. And then put the wee square in there. Like you just tell the examiner there really that you understand the angle between the boundary and the normal is indeed your 90 degrees. So again, pause the screen and have a little go at this one yourself. Moving on to number 4 now. We want to quite simply label the angle of incidence. And that's again quite similar to the previous diagram from the incident ray to the normal. So just again, take a few seconds, pause the screen and add that into your existing diagram as well. Now, moving on to number 5, and look, you can see I put a wee hazard sign here. Like you got to be super careful here. This is where things can go south quite quickly. Now, when you're dealing with these waves, we're going from deep water, which is fast, and we're traveling into shallow water where the waves actually slow down. And when we get this slowing down, we need to be aware that the waves will then bend towards the normal. You might want to maybe again pause the screen, just copy out this wee mental model I use personally to recall what's happening to water waves. You'll remember the deep to shallow because whenever waves come in, like they slow down so much, they sort of fall on top of themselves. And that's why the waves crash, and that's what we see really at the seaside and so on. So again, just pause the screen and just copy down this key information as well. Now back up to this diagram, we now know, of course, that this wave is going to bend towards the normal. So two things to be super careful about for this refracted ray here. Number 1 is the direction, making sure you're bending downwards in this case and you're putting that refracted ray closer towards the normal. Number 2 is the angle of deviation. And you want to make sure the angle of deviation is big enough that the examiner can see it. Now it's useful here when you've got AutoCAD to use, but if I was to take that ray out, that's it coming straight through. And if I swung that ray around by, for instance, say 2 degrees, that's not really noticeable enough for me. So even though this student here has refracted the ray, they've bent it downwards, that looks like it's straight compared to this one. And so I would recommend whenever you're refracting your ray to bend it by at least 15 degrees, just so the examiner can see very clearly that it has been refracted. So again, just pause the screen, copy down these notes, but just again, make sure you refract it the right way, but you also refract it by at least 15 degrees. Now, going on to number 6, we now want to quite simply label the refracted angle. So very straightforward, we're going from the normal here to your refracted ray. And again, just label that in your diagram as well. Moving on to number 7, we now want to add in these construction lines here, which will aid us for the completion of the last part of the diagram. Now, these are not required by C or whatnot, but I just think that they're very useful come to stage 8 when we start to sort of draw in these refracted rays. Now, all I'm doing here really along this top edge, where these blue lines end, where these wave crests or wave peaks end, just take a straight line across the top edge and then get to the boundary. Now do something similar along the lower edge, just where these lower edges stop, just take a straight line along that boundary until it strikes the boundary, sorry, as well. We then want to take these two lines here, these two construction lines, and I'd make them dashed. Again, just to sort of differentiate them from any other type of ray, like even a wave crest. So the only construction lines make them dashed, but these two should be parallel to your refracted ray, which you've drawn in the previous step or 2 steps ago before you've labeled the angle. Now you can see, of course, the parallel, the double dash, the double dash, and your double dash here. All right, so just take a few seconds and just add in those construction lines to your diagram as well. Now, moving on to stage 8, we're now going to try and draw in our first new wave front. And again, we're just going to take this in a number of stages because this is where it gets tricky for students and they tend to make a complete mess, quite frankly. Now, you want to go to your first wave down here that has hit this boundary. And you want to draw a line, of course, a pencil and a ruler from here. And you should be taking that line till it intersects your construction line from the previous phase. Now, your intersection needs to be such that the angle between your wavefront and this construction line, as you can see, a wee square, it should be 90 degrees. So just take a few seconds, go down carefully. That's why, again, it's good to have a good big diagram on your page and just showcase your first ray in there and also put the wee square in there for the 90 degrees as well. Now, moving on to stage 9, we're just now really going to complete that process again for the next wave, which is intersected the boundary, and the next one. And you can see in my diagram, there's 4 waves that have sort of been cut short because they've hit the actual boundary. Now, it's the exact same situation in each case. Go to the intersection point and then draw a line down, but your line must intersect this construction line at 90 degrees. You can see again the wee squares going in there. So again, pause the screen, go back to your diagram, and just do the exact same operation as well. Now at this stage, we're sort of nearly home and dry, to be honest. The last thing is let's just add on more 3, about 3 more. If 3 is usually fine, most of the mark schemes, to be honest, too. But go for 3, like, and put in 3 new wavefronts, really, which showcase 3 full wavefronts coming on ahead on a refract on the far side. Now to do this, literally measure the wavelength by going from one of your new waves here and just measuring across that distance on your page. I could use CAD here, and I can just take a dimension from here to here. And then whatever that happens to be, say 13.5 millimeters on your page, you just come down and then put a wee dot down. So put your ruler down here, come down, put a wee dot down at that exact same distance. Measure out the same distance again, put a dot down. Measure out the same distance again, put a dot down. And then literally draw in these 3 new wavefronts. And the angle between them and this construction line is also 90 degrees. So even though there isn't squares put in there, I could have perhaps copied them in there just to sort of make it perfectly clear that those last 3 are also at exactly 90 degrees. So there's absolutely no confusion there. So to dot in those last three wavefronts, again, you must intersect that construction line on the bottom at 90 degrees. And when you do that successfully, you can then just continue those wavefronts up until they intersect the top construction line here, and just basically don't go beyond that construction line. I find when you put these construction lines in, it keeps the diagram a lot tidier, gives a nice edge along the top and the bottom, and it does look much, much more professional as well. And that's your diagram complete. Unlike the reflection, we don't have to compare the wavelength before and afterwards in this case because they're not constant. You can see very clearly, of course, the wavelength is decreased as this refraction has taken place. And if you can get this diagram done correctly, again, you could be looking at 4+ marks in the exam from SIA. They are difficult. You'll have to practice them quite a few times.